Welcome to weeks 10 and 11 of this course on real analysis. In weeks 8 and 9, we had a whirlwind tour of both differential and integral calculus. Now, you might question, what is the use of this theory of differentiation and integration of functions when I don't have a good toolbox of functions available for me? Well, weeks 10 and 11 are to remedy this situation. We are going to look at the famous functions like exponential, logarithm, cosine, sine, etc., which are the toolbox using which physics is conducted, for instance, in a deeper light. For that, we need the machinery of power series. Power series are infinite expressions of the form summation an x bar n. This looks very similar to a polynomial, except there are infinitely many terms, so loosely you can think of it as an infinite degree polynomial. Because they look like polynomials, you might expect that these power series are also functions that behave like polynomials. But first of all, is a power series even a function? If you look at the expression summation an x bar n, other than x equal to 0, it's not clear that the series converges at all. So the first order of business is to understand at what points does the power series converge, and is there some way by which we can describe the region in the real line on which this series converges. We will undertake this project. The second question is, now that we know that the power series does define a function, does that function defined by the power series behave nicely? Since polynomials are the nicest type of functions, you would expect that power series, being nothing but infinite degree polynomials, continue to be nice. This intuition is really good, and it will continue to be true that this function defined by power series has a number of nice properties, but we need to study something called uniform convergence to understand this. Essentially, the convergence of this series summation an x bar n is not just pointwise. There is something uniform about it, and that uniformity is what is going to make the limit function nice. So we study uniform convergence at some length, especially the facts about the behavior of uniform convergence under both differentiation and integration. You will learn that uniform convergence behaves much better with respect to integration than with respect to differentiation. So this is a mistake that students often make. They think that the uniform limit of functions like summation, an x bar n will continue to be as nice by interchanging differentiation and summation. That's not quite true. We have a precise result that is weaker than what you would expect. Once we have this machinery of uniform convergence and power series, we can go on and define exponential, sine, cosine, logarithm, etc. in the usual way. You have already seen series expansions of exponential and the trigonometric functions in school, and we will make that the definition of these functions at this higher perspective. Once having defined these functions using power series, we will prove the basic properties using the results developed in week 9. This will be the week 10. We will use the various properties proved in week 10 to prove the various properties of exponential, logarithm, sine, cosine, etc. in week 11. Now, one thing I will not do is prove the various trigonometric identities that you were tortured with in 11th and 12th standard. There are literally hundreds of them. There is an entire book on trigonometric identities. This is a fruitless exercise in my opinion, simply because when you eventually get the opportunity to learn complex analysis, you will learn that using the complex exponential, all of these identities can be proved more or less trivially. So you need to know only the very basic properties of the trigonometric functions for your scientific career, and I am going to focus on those. What I will do is do a careful analysis of what is pi, why does the graph of sine look like what it looks like. We can do all this using the tools of calculus that we have developed. It will also be a very instructive exercise because we will be taking derivatives and second derivatives and seeing where the function is increasing, where the function is decreasing. So it's a fruitful exercise. So this sums up the content of weeks 10 and 11. It's not very difficult material. We will be revisiting high school level material from a higher perspective. The only new thing is uniform convergence and power series, which I urge you to pay careful attention to. All the best for weeks 10 and 11.